Okay, so just like any of your graphs, like your lines with your slope and your y-intercept and your quadratics, you can shift your graph all over your coordinate plane, shifting it up, down, left, or right. So we're going to talk very quickly about how we can graph our radical functions and how we can use our values to determine how our original graph shifts. So to graph a function, y equals a square root of x minus h plus k, or y equals a times the cube root of x minus h plus k, follow these following steps. Okay, so a couple quick things is we know what our original functions are. Our parent functions are typically y equals the square root of x, or you have an a out in front, or y equals the cube root of x. Those are our two parent functions for our square root and cube root functions, with maybe an a out in front. Typically, this is how it's always going to translate for all of your graphs. Now, we don't have to worry so much about our h and our k. I just want to make sure we talk about knowing what those values mean inside or outside of our radical symbol. Your h typically is the number inside of your radical symbol. If you have a number inside your radical symbol, like a +1 or a -5, you are going to translate your graph horizontally, left and right, so it's going to be according to your x-axis, opposite units that are given to you. Alright, we'll talk about what that means in a second. So it's going to move horizontally. So your h value, the value plus or minus inside your square root, just like if I had y equals the square root of x minus 1, that means I'm going to move my graph 1 unit to the right, opposite of what you think, along your x-axis. If you have your k value, which is outside of your radical, okay, so something like y equals square root of x plus 5. If that value is outside of your radical symbol, you're going to move your graph up or down true to its symbol. So as is, you're going to move it true to its symbol. So if it's +5 on the outside, you're going to move it up 5 units. If it's -5, you're going to move it down 5 units, because your outside values move according to your y. Your inside values move according to your x-axis. Inside, you're always moving opposite of what you think. Outside, you're moving true to its symbol. Okay. So let's look at example 3, just to give you kind of an idea of how these move. So in example 3, we want to compare the two graphs. So obviously our parent graph, our original graph, is y equals square root of x. How does y equals square root of x plus 1 minus 3 translate if our original graph is y equals square root of x? So, if this is our original, how is this one different from our original? And what that means is, because my +1 is inside my square root, I'm moving opposite of what I think it is along my x-axis. So since I'm +1, I know my graph right off the bat is going to move 1 unit. We would think it would be to the right because it's positive x and positive x-axis, right? Positive x means you're moving to the right, but it's always opposite. Remember, it's opposite. So if it's +1, I'm going to move opposite, which is to the left 1 unit. And then the -3 on the outside, because it's not part of my radical symbol, -3 is going to be true to its symbol, and it's going to move up or down. And because it's -3, I also know I'm going to move 1 unit left and 3 units down. So my original graph, which would probably start at 0, 0 as one of my points, is going to move all my points 1 unit left and 3 units down for its new graph.